Hello, this is the first video in my linear algebra series. Today I will be discussing systems of linear equations. So what is a linear equation? Well, a linear equation is an equation that can be written in the form a1x1 plus a2x2, so on and so forth, an xn equals b. And if that is the definition of a linear equation, then a system of linear equations is just multiple linear equations that have the same variables. Now I have 3 example problems to show you. For the first one, we're going to use the elimination method to cancel out the x1 variables. Doing so, we add both equations together. We get 0 plus x2 equals 4. So x2 equals 4. Then we substitute that value of x2 back into one of the equations. I'm going to choose the top equation, so I have x1 minus 2 times 4 equals 1, or x1 equals 9. So the solution to this problem is x1 equals 9 and x2 equals 4. Moving over to the right, I'm going to multiply the top equation by 3 to cancel out the x1 variable again, and this time subtract the 2 equations. And I'm left with 0 plus 0 equals 0, or 0 equals 0, which means there are infinitely many solutions to this system. And onto the last equation, last system of linear equations. I'm again multiplying it by 3, subtracting to cancel the x1 variable. And I'm going to be left with 0 minus or plus 0 equals 2, or 0 equals 2. We know that 0 does not equal 2, so this is no solution. And the purpose of these 3 systems was to show you that for systems of linear equations, there are 3 possible outcomes. Either there's a unique solution, as seen in the first system, infinitely many, as seen in the second system, or no solution, which we saw in the last system. Now, to provide a formal definition to what a solution is or solution set is in a linear system, which is the same as a system of linear equations. So a solution is a list of numbers we're going to call S1 through Sn that make the system true when the values S1 through Sn are substituted in for x1 through xn, which we saw in our definition of a linear system, which was a1x1 ... an xn. So we're substituting in the S1 for the x1 and the Sn for the xn. And a solution set are all the possible solutions of the system. So going back to the examples we just looked over, the solution set of the first system was x equals 9 and x2 equals 4. How do we know if 2 or more systems are equivalent? Well, that's easy. If they have the same solution set or share the same solutions, then 2 systems must be equal. What does it mean for a system to be consistent or inconsistent? Those 2 are opposites. Well, a consistent system is a linear system that has one solution or infinitely many solutions. So, in other words, it has at least one solution. While an inconsistent system means that the system has no solution. And we can also say that the solution set is empty. Going back to the previous examples we did, given that the first example had a unique solution, we know that it must be consistent. And the second example has infinitely many solutions, or at least one solution, so it is also consistent. And on to the last one, well, we said it was no solution, so therefore it's inconsistent. And that wraps up today's video. Next time, we're going to be discussing matrices.